In this video, we'll understand convolutional neural networks from scratch in a simple step-by-step way. We'll see why CNNs are so powerful for image data, how convolution and pooling really work, and how a CNN can be built for plant disease recognition using Keras. Along the way, I'll test your understanding with quick quizzes as well. A convolutional neural network, or CNN, is a neural network specially designed for image-related tasks. It learns patterns like edges, colors, textures, and later even bigger shapes and objects. That is why CNNs are widely used in computer vision tasks, such as image classification and object recognition. A typical CNN has three main kinds of layers. First comes the convolutional layer, where feature extraction happens. Then pooling layers help reduce the size and complexity of the data. Finally, fully connected layers use the learned features to make the final prediction, like whether an image shows a healthy plant or a diseased one. CNNs learn in stages. The earlier layers usually detect very basic features like edges, corners, and color transitions. As the image moves deeper through the network, the model starts combining these simple patterns into larger shapes and more meaningful structures. So deeper CNNs can understand more complex visual information. Now let us look at this in a simple table format. CNN layer roles. The three core parts of a basic CNN. Let's pause and organize the core CNN structure. Convolution layers extract features from images. Pooling layers reduce dimensions and simplify the representation. Fully connected layers then use those learned features to perform the final classification. This is the main flow of a basic CNN. The convolutional layer is the heart of a CNN. It takes the input image and applies a small filter, also called a kernel, over it. At each position, it computes a dot product between the filter values and the image pixels. As this filter slides across the image, it produces an output called a feature map, which highlights useful patterns. Now that we've covered CNN basics, let's test what we've learned so far.
Here's quiz number 1. See if you can get it right.
Question 1. Which layer is mainly responsible for feature extraction in a CNN? The correct answer is convolutional layer. The convolutional layer performs the main feature extraction by applying filters over the input image. Question 2. What do early CNN layers usually learn first? The correct answer is edges and simple patterns. Earlier layers focus on simple visual features like edges, lines, and color transitions. Question 3. What is the output of a convolution operation commonly called? The correct answer is feature map. The result of applying a filter across the image is called a feature map or activation map. Before training, some important convolution settings must be chosen. The number of filters decides how many different feature maps the layer will produce. Stride tells us how many pixels the filter moves each time. Zero padding helps control output size by adding zeros around the image borders when needed. Padding comes in different forms. Valid padding means no extra border is added. Same padding keeps the output size equal to the input size. Full padding can even increase the output size. After convolution, a ReLU activation is usually applied, which adds non-linearity and helps the network learn more powerful patterns. Pooling layers reduce the spatial size of the feature maps. In max pooling, the highest value in a small region is selected. In average pooling, the average value is taken. This makes the network more efficient, lowers computation, and can help reduce overfitting as well. After convolution and pooling have extracted and compressed the important features, the fully connected layer takes over. Its job is classification. For multi-class problems, softmax is commonly used here to produce probabilities between 0 and 1 for each possible class. Now that we've covered layer functions, let's test what we've learned so far.
Here's quiz number 2. See if you can get it right.
Question 1. What does stride control in convolution? The correct answer is the filter movement step. Stride tells us how far the filter moves across the input each time. Question 2. Which pooling method selects the highest value from a region? The correct answer is max pooling. Max pooling keeps the maximum value from each receptive field. Question 3. Which activation function is commonly used at the final classification layer for multi-class output? The correct answer is softmax. Softmax converts outputs into class probabilities that add up to 1. CNNs are powerful because they solve real-world image problems. In healthcare, they help detect medical conditions from scans. In agriculture, they can identify crop issues. They are also used in social media for face tagging, in security for surveillance, in finance for chart pattern analysis, and in automotive systems for self-driving research. In the article's practical example, the CNN is built from scratch using KRS for plant disease recognition. The dataset contains 530 images split into training, testing, and validation sets. The three classes are healthy, rust, and powdery, which represent different plant conditions. Before building the model, it is important to explore the dataset properly. We should check whether the classes are balanced, whether image dimensions are consistent, and whether pixel values are in the expected range. In this case, the classes were reasonably balanced, but the images had multiple dimensions, so pre-processing was needed. CNNs need images of a fixed size, so the images must be resized, for example to 256 by 256. Since many original images were rectangular, they also had to be adjusted into a consistent square shape. Pixel values can then be normalized, and TensorFlow's image_dataset_from_ directory makes it easier to load, batch, shuffle, and prepare the data for training. Now that we've covered dataset prep, let's test what we've learned so far.
Here's quiz number 3. See if you can get it right.
Question 1. Why was pre-processing necessary for this dataset? The correct answer is images had different dimensions. CNNs require a fixed input size, and the dataset contained images with multiple dimensions. Question 2. Which of these was one of the plant classes in the dataset? The correct answer is rust. The dataset classes mentioned were healthy, rust, and powdery. Question 3. What is a key benefit of image_dataset_from_ directory? The correct answer is it automatically organizes image loading and batching. This TensorFlow utility helps load images from folders and supports batching, shuffling, and pre-processing. That's the CNN from scratch idea in a clean and practical way. If you understood how filters, feature maps, pooling, and pre-processing fit together, then you already have a strong foundation for building image models. Keep practicing with small datasets first, and then move on to deeper architectures like VGG or ResNet.